I deployed this object detection model known as YOLO using this ROCK4, a camera, and a power bank. If you want to know more about how this is done, then this video is for you. In this video, I will talk about the YOLO model in general, the research paper, then the different components that were added later on or different versions. Then we'll jump into talking directly about the hardware, what hardware was utilized, plus the tools that we used to deploy such models. Finally, we'll talk about how we utilize the Python libraries, mainly the Ultralytics library, which was introduced later after the release of the paper. So let's not wait much and start with it. You Only Look Once, a paper that was published around 2016. It reported a new approach for object detection and showed reliable performance, providing a base for additional advancements later on with different YOLO versions. New YOLO models are regularly released these days with different sizes such as nano, small, medium, large, and extra large. Although such models are trained on public data, you can train on your own custom datasets. With this in mind, you might want also to run such models in your own way. The YOLO models or the YOLO versions enables different machine learning tasks. We have spoken about object detection, but YOLO models can be also utilized for segmentation, for oriented object detection, classification, and so on. With this in mind, what if you want to deploy such outcomes or such trained models on the edge? Meaning by that, making it closer to where the data sets are generated. What if you want to benefit from such models in an offline environment and deploy that in small devices? That's where the ROCK4 comes into place. The ROCK4 C+ is a single board computer that is used in edge computing, Internet of Things, and can be even used as a lightweight computer. It is similar somehow to the Raspberry Pi. It can be used to deploy machine learning models, including the YOLO model. Let's quickly check together the different components of this device. I've got this image from the official documentation of the ROCK4 C+ model, and these are the different components. For the processor, it comes with a ROCK chip RK33992. For the RAM, it comes with the LPDDR4 RAM. For storage, there are two options, which are on the other side. There is an eMMC connector, and there is the microSD connector, which is the one that we have used in this tutorial. For the display, there is the micro HDMI 4K, there is the micro HDMI 2K, there is also the MIPI DSI, which stands for Mobile Industry Processor Interface, and DSI stands for Display Serial Interface. So this one can be used with LCD displays, for example, if you got the right connection, while the other ones can be also used with monitors and so on. With this device, you can also use Wi-Fi and Bluetooth. At the same time, there will be an antenna to connect to Wi-Fi. Other details includes 4 ports for USBs. Two of them are USB 2.0. Two of them are USB 3.0. There is also support for Ethernet connection, plus one option to utilize audio. Finally, there are 40 pins over there, as you can see, for general purpose input output, and those can be used for sensors, for example, and so on. Such devices require an operating system to be able to run. There are multiple operating systems that are available for download in Radxa website. So all you need to do is to go there and check the different operating systems. I've personally selected a Debian-based image with a lightweight desktop environment, and it is referred to as XFCE because I like graphical user interfaces. While the operating system was being downloaded, I prepared a 64 GB microSD and a microSD reader, which was connected or is used to connect the microSD to my laptop. The next step was to flash the operating system that was downloaded on the microSD and later on insert it to the ROCK4 C+ model. I've used a software which is called Balena Itcher in order to flash the microSD. This process allows installing the operating system on the microSD. You can assume you are creating a C drive of the device. You can see this is the downloaded operating system image. We don't copy paste it directly, we have to flash it as mentioned previously. So I open the software. Then I've selected this image. Make sure to select it's on the micro SD. You want to flash it on the micro SD, not anywhere else. And then just click on the bottom next to it. It will go through multiple steps, decompressing, flashing, then there will be a validation step, and that's where it will be ready to be used. I then took the micro SD from the reader and inserted that to the back of the board, followed by connecting the micro HDMI to the micro HDMI connector. This will be later on to use to connect to the monitor. Putting the USBs or the connectors to the keyboard and to the mouse, followed by connecting the USB camera. The final step was to connect the USB-C for the power. Once you turn it on, you will see these lights showing, and the first time you connect it to the screen, you will see the setup this way. For me, this was the user interface that I saw. If you chose another operating system, you will see a slightly different interface. I personally wanted to check different components. The first thing that I've checked was the memory, making sure that the RAM is there is sufficient RAM. Then I quickly tried to connect to the Wi-Fi and tried to check a conflict that I've noticed. There was the port 53, which was related to some DNS servers or DNS applications was showing up some conflict. What I've done, I've handled that using the following scripts. I've then enabled user access to the USB camera. Finally, I checked if Python was installed, and this was the case. Then I created a Python environment, which I named in here YOLO_env. Since it's Linux, I had to go with source YOLO_env/bin/activate to activate the virtual environment. Virtual environments are actually useful because it allows you to run each project in a separate container, you can assume. For my application, I just needed to install Ultralytics, which contains the YOLO modules, and OpenCV Python, which allows working with videos and images. Once I ran pip install, you can see the following libraries and the dependencies being downloaded. Finally, this is what will be shown when everything is ready to go. The next step was to write up a script that will allow loading the YOLO module and running it, then recording or saving the output of the YOLO into a video. So to start with, I'll just do a print starting the application. This allows us to see that it's starting in the CMD later on. I will load the YOLO model with YOLO, and then as mentioned, I'll be using YOLO version 8 nano model. So this is it. And what will happen is that if you don't have it, if you don't have that model, this will allow you to download it. The next phase or the next step is to initialize or to set up the webcam. You have seen in the previous sections that we had to enable using the webcam. So what will happen is that is going to be using OpenCV, cv2.video capture, and then it will be default one, which is the 0. So if the cam is not opened, so if it's open, what will happen is that we will raise an error, or we will go into raising an error, runtime error. Runtime error. And that is going to be camera not detected. Then I will quickly write up some scripts for setting up the frames and working with the frame width and height. That basically I added that for one reason, which is to make it a bit faster, because I noticed it was slow when having like a large or high frame sizes. So this is the script. I purposely kept this because maybe you want to remove some, or you want to go a bit slightly different in your tutorial at your site. The next thing to be done is to set the frames per second, which was selected to 7 in my scenario. I had to do multiple trials to find out the ultimate frame per second myself. Then setting up the output file, that will record, or that will save the video after stopping the application. File.mp, or in this case. Then I've added the following 2 lines of code to create a video writer object to save the output video that we want to see, or that I've showed you earlier in the beginning of the video. Now setting up some variables to work with the frames per second. I want to show on the video the frames per second values. And now starting the application. So while true, what we will do is that we will get the frame from the camera, capture per dot read. Then if we had an issue, we will break the application. Then this is the next phase, which is to run the YOLO model on the frame. So results equal to model of frame, and then we will use the image size. Because we have changed it a bit, what we will do is that we will use it as frame dot shape underscore frame equal to results dot plot of 0. Sorry, the results of 0 dot plot is the frame. We want to add this annotated frame to the video that we will generate. So it will be out dot right, and then it will be the annotated frame. Now what we will do is that we will add, or we will calculate the current time and estimate the frames per second. The main reason of me doing this is that I wanted to put on the top left side on the YOLO live show when testing it on the graphical user interface. The final thing to be added is to enable breaking of this loop, or this while loop. Finally, the final step is to release the camera and stop capturing the video, in addition to stopping the video writer, and closing all the OpenCV display windows. The code was saved in the Radxa ROCK4 model. Then what was done is the environment was accessed from the CMD, which is the YOLO env, followed by running the following script, Python, and I named the file as cam_test.py. And you can see this is the output of the YOLO with the frames here. Here is a quick example or a demo of what was processed using the YOLO version 8 nano model. You can see this model is trained on 80 different objects, including trucks, buses, and cars, traffic lights, and so on. And assuming you might want to train custom models yourself, for example, analyzing the type of vehicles that crosses this particular road, then such models can be a valid approach to be utilized. Again, lots of applications that can be done with this on the edge. That's how you deploy YOLO using a ROCK4 C++. Thank you for watching.